Welcome to part 1 of the basic browser video series. We will focus primarily on the use of accession names, the many ways that identifiers of various kinds can be used to locate genomic locations and annotations. We will also show a few configuration options for setting up the browser. In the next installment, we will focus on more ways that the browser image can be configured to show the data the way you want. In part 3, we will show you many more configuration options and also how you can use DNA sequences to navigate. In this part, we will deal mostly with navigation and how to get around in the browser. To start with, let's set our genome browser to the default settings, reset all user settings, and then from the gateway page, we will choose the human HT19 genome. That genome assembly is still the most popular genome among the human genome assemblies. Hit the Go button to get into the genome browser. We have a large number of data tracks turned on by default in the browser graphic. We define track as a set of data with at least one database table underlying it. Typically, all data in such a table will be of a similar type, such as gene predictions, mRNA mappings, or transcription factor binding sites. Let's simply turn them all off. We'll hide all the browser tracks using the Hide All button. To find a place to start with, let's simply type in a gene name in the position box. Let's go with EGFR, and we notice that it comes down in the drop-down menu as one of the options. We can select that and hit Go, and the browser will navigate to the EGFR gene and turn on the appropriate gene track. In this case, the Ucsc genes track. There are other ways to navigate within the browser to get to particular locations. For example, in the position box, you can type in the name of a gene and the number of a particular codon if you wish to navigate to that codon. For example, FGFR2 followed by a space and a P with or without a dot and 33 will take you to the 33rd amino acid of the FGFR2 gene. You'll notice that a second gene set has come on in this case, the NCBI RefSeq genes. The nomenclature we use for the P-dot syntax is keyed to the NCBI RefSeq gene set, and so whenever you use that type of navigation, it turns on the RefSeq gene set. It is presented on the screen in the center with 5 bases on either side. And you can see that sometimes the numbering is different. If there's been an upstream splicing, you may get different number for some of the isoforms. For example, leucine 33 here at the center of the screen is also annotated as leucine 52. You may notice that this particular gene is transcribed and translated on the opposite strand, so the numbering goes from right to left. You can switch the orientation of the DNA at the top of the screen by clicking the little arrow at the upper left corner, which reverses it, so that the TTA codon that you see in the window reading from right to left matches what you would see in the codon tables. I'll switch it back now to have it in the normal genomic order from left to right. A number of other things can be typed into the position box, such as the reference SNP identifier of a particular nucleotide variant out of dbSNP. For example, RS10000. If you type that and hit Go, you will get a number of different hits on this page, indicating that the particular variant is found in a number of different releases of dbSNP. The higher the number, the more recent the version of dbSNP. So we'll just turn it on in the All Short Genetic Variants from dbSNP 153 track, and you can see that we are going to go to chromosome 7. The SNP track comes up with the variant you've chosen highlighted in faint yellow coloring in the background. The label of the individual variant is written in reverse video, where it is white against the colored background. In this case, it's a green background because the variant is a synonymous variant. It does not change the amino acid. So let's continue to look at ways to get around in the browser using various accession numbers, names, and identifiers. And to do that, let's turn off, using the right mouse button, the All SNPs track, and will also turn off the NCBI RevSeq track and leave just the UCSC genes track turned on. Another type of identifier that you can use is a RevSeq identifier. For example, NM_014877.4. And you'll notice once again that the RevSeq track comes back on and we're navigated to the HELZ gene and it is highlighted. If there are multiple isoforms, the various isoforms will have different NM numbers, and the one that you typed in is the one that is highlighted. The browser also supports OMIM identifiers, online Mendelian inheritance and MAN, for example 115500, and hit go. It's the only type of identifier the browser recognizes that has just integers, and it looks it up in the OMIM table, and you can see that it is highlighted here. The OMIM gene track comes on, and we have navigated to the catalase gene. Typically, when any browser track comes on, and you click into the browser item, the item in the track takes you to a details page. In this case, you can click through to the gene at the OMIM website or to the phenotype record. You can see here the 115500 matches the identifier we put in, but there is also a phenotype identifier, 614097, and if you click into that, it takes you to the OMIM page for acatalasemia. We'll just close that window and navigate back to the genome browser. There are a number of other ways to navigate in the browser. For example, you can use genomic coordinates if you'd like. Click on these coordinates on the left to get them into the edit box. You can simply tweak the end coordinates by adding 100 on one side and subtract 100 on the left side, and you would go from a 33,127 total window size to a 33,327, and you've put a little bit of white space on either end of the gene. You can also add a little white space on the end of the gene by nudging the edges here. If you click to the left on the Move Start, it moves over a little bit. If you click on the right, you can do the same thing and move it over a little bit. And if you want, you can change the number next to the arrows, and it'll change the magnitude of the nudge. The number represents the number of light blue lines that you will move. So let's look at the coordinates again. We'll click over here in the box and put the coordinates into the edit box and go in and just remove the commas and hyphens and the colon so that you get the coordinates in a format that you might have seen in another application, or you copy-pasted it from another application. In fact, it is now possible to remove the CHR at the beginning of the chromosome name and simply enter the coordinates here. And so, if you click Go with those coordinates in the window, you see it goes to the same location as it was previously. It's also possible to put in just a single coordinate to go to a single nucleotide. For example, you can type in chromosome 11 colon 344777700 and hit Go. That'll go to that single nucleotide. And that's the only nucleotide on the screen. What does not work is putting in just the bare chromosome number without the CHR in this format. When you type in a single coordinate, the CHR and the colon are required, but the commas and the number are not. You'll notice that when you're zoomed in to an exon far enough, there's room enough on the screen to show you the amino acids and the amino acid number. Then by default, the number gets turned on in a number of our gene tracks. You may also have noticed when we put the mouse over the exon that you get an exon number here for each one of the isoforms. You might get a different exon number for different isoforms at the same location. And it tells you how many exons there are in the gene and which exon your mouse is at. There's also a double-headed arrow at the end that takes you to the end of the exon or the start of the exon on either end of the screen. If you'll click that, it'll go all the way to the end of the current exon. So here we are at the leftmost nucleotide of this exon. you'll notice that if we zoom out by a factor of 3 to get a little more on the screen, we pick up the next nucleotide in each direction, and you can see that the intron right next to the exon is shown. The intron is shown as a thin line with arrowheads showing the direction of transcription and translation. Let's go back to the position we were at before on chromosome 11, 344777700, and then zoom out a few times. If we zoom out by a factor of 10, we're at a 10 base window. And then another factor of 10, we're at a 100 base window. You'll notice that the methionines in the browser are always colored green. Some of them are a start codon, some of them are not, but they're always green. At this resolution, there's no room to write the amino acid numbers, but the amino acid names are still there in single letter code, and then zooming out again by another factor of 10, there is now no longer room to put the amino acid symbols in there either. And so it's just an alternating light and dark color indicating the codons. That saves you the trouble of having to subtract two numbers from the scale bar and then divide by 3 to estimate how many amino acids you might have in your window. Yet another way to navigate in the browser is to use the cytological band nomenclature. For example, up here you can see we're on chromosome 11, and you can see that here's band P15.1. Before I use that, 11P15.1, I'm going to turn off at least one of the gene tracks because we're going to get a lot of genes in the window. And then I'll hit go, and you'll see that we are highlighting in red in the chromosome ideogram the region of that cytological band. Cytoband nomenclature is useful when navigating on the human, mouse, and Drosophila genomes, all of which have well-established cytology. You'll notice that the chromosome band track came on, and so 11P15.1 is shown here. If I put my mouse in the window and drag it over to the left, then the next band over here will also show up in that track, and you can see 11P14.3, so that's the next band closer to the centromere. It's worth mentioning that the P arm is always on the left. You'll notice when you zoom out that you get a lot of genes with a lot of isoforms in them, and it tends to clutter up the screen. So it's useful to be able to turn those off if you're looking at this large-scale resolution. For any one of our data tracks, over here on the left is a little gray bar that turns to blue when you put the mouse over it. Note that the background of the track is light green. Each track has a label in the middle of the image, even if there is no data in the window being displayed. If you wait long enough, the mouse over on this bar tells you that you can click it to get to the configuration page, and one of the configuration options for the UCSC genes track is that you can turn off the splice variants. On HT38, it's on the GenCode genes track. When you do that and hit submit, it cleans up your screen a little bit, showing only the canonical transcript for each gene. The button on the left side of the track that we used to access the track configuration option is not the only way to get to that page. If the track is not turned on, then it is convenient to use the configuration option available by clicking the link above the pull-down menu for any one of the tracks. If we click once again into the UCSC genes track, you can see that it's the same page and it has the splice variants option. At the bottom of the page on any one of our tracks, you can see a description that tells you why the data are useful, how they were developed, and a bunch of other information such as color options and a list of references at the bottom of the page. If I go now back to the genome browser, I can show you yet a third way to access those configuration options. For any items in the track, if you use the right mouse button, you have the option to configure the track in a context-sensitive menu, except that in this case you do not get the track description, but you do get all of the configuration options, the splice variants, and so forth that we saw before. That concludes part 1 of the basic browser video series, which has primarily focused on the many ways accession names from a variety of datasets and data types can be used to find your way around the genome. There are other accession names that work as well, the best advice is to just give it a try in the position box. We will start part 2 at the same genomic location. To make it easy to find that location again, we will save the configuration for easy access. The Saved Sessions feature is the subject of a separate video in the UCSC browser video collection, so it will not be repeated here. Please note that we conduct full-day and 2-day on-site trainings at your institutions. Prices are reasonable. Visit genome.ucsc.edu/training/. Thanks for watching, and thanks for being a UCSC Genome Browser user. Welcome to part 2 of the Basic Browser video series. In part 1 of the series, we focused on the use of accession names, the many ways that identifiers of various kinds can be used to locate genomic locations and gene annotations. We also saw a few configuration options for setting up the browser. In this installment, we will focus on many more ways that the browser image can be configured to show the data the way you want it. At the end of part 1, we found ourselves on chromosome 11, with several datasets turned on. To make it easy to find that location again, we have saved the configuration for easy access. The Saved Sessions feature is the subject of a separate video in the UCSC browser video collection, so it will not be presented here. The session was saved under the username VideoDemo1 and the session name hg19_nav1. The session can be accessed directly in any browser using the URL genome.ucsc.edu/s/videodemo1 with a capital D /hg19_nav1. This returns us to that same location with all the configuration options intact. It is possible to export an image from the browser in a number of ways. If we use the right mouse button to view the image, then it'll draw the browser image from the middle of the screen. And then you can save the image to a directory as a PNG file. The PNG image will get pixelated, however, if you try to zoom in, and is only at screen resolution. Let's go back and look at the browser. There is another way to view the image, which is useful for getting a graphic for a publication, which is required to be at much higher resolution. So if I click the PDF/PS link up here in the View menu, then you're able to download the current browser graphic in PDF format. And if I open it with Adobe Acrobat, I have a PDF version, and then this PDF version can be viewed at very high resolution, and because it's vector graphics, it doesn't get pixelated when you zoom in. And so you can save this and then open it up in an application such as Photoshop, where you're able to modify the resolution, save it at 300 dots per inch or even higher, so that you can grab just a part of the screen. So if I go back now using the back button, back to the browser graphic, an interesting feature to know about the browser is, in case you wanted to save an image that wasn't quite as wide as this one, the browser will redraw the screen for you if you just shrink the size of your Firefox or Chrome browser window and make it a little narrower. There's a button below the browser graphic called Resize, which lets you choose the size of the window that you have, and then your graphic is redrawn to fit the window with all the annotations on the screen. So you're not faced with the prospect of making it smaller and then making the type misshapen if you resize it asymmetrically. Speaking of type size, there's a configuration button below the browser graphic that gives you the option to change the font size. You can change the text size, for example, from 8 to 12 and make it really large, and then submit that and go back to the browser graphic, and it will redraw the browser with text at that larger size. So I will reset the browser window to the size of window we had before. Scroll down below the browser graphic and resize it so that it's back at its original size. If you go to the Genome Browser pull-down and select Configure, which has the same effect as the button below the browser graphic, then you can go back to the default size of 8. Note that this is a global configuration, distinct from the bar at the left side of the data tracks, which is a configuration option for that track only. Let's have another look at ways to get around in the browser and configure some of the options. To do that, let's go to this gene NEL1, and we'll put our mouse over the base position at the top and move it just a bit to the right and catch that exon and put the exon in the window. And we'll do it one more time and zoom into this exon right here. And you'll see that we have the stripes that show the alternating colors. And when we put the mouse over it, you can see that this is exon number 6 out of 20. The little double-headed arrow on the end says previous exon, and on the other side of the screen it says next exon. This gives us options to jump from exon 6 to exon 5. There's another configuration option that helps you get around in the browser. If you click again on Configure, you see the only unchecked box on the configuration page, Next Previous Item Navigation. Let's click on that one and submit. And now you get these gray double-headed arrows. Each track has one at the very top of the data at the same location in the horizontal dimension as the long label for the track. And so let's click on the double-headed arrow for the UCSC genes track, and it will go to the next gene in the window, SLC6A5. To confirm that it really worked the way we think it did, let's zoom out by a factor of 10 and then another factor of 10. And here we pick up the NEL1 gene, which is the gene we were on before. Let's go back to the configuration page. I'll use the button below the browser graphic this time. And we'll turn off the next previous item navigation, and we'll also turn off the light blue guidelines that are in the browser image. Some people prefer to make images for their papers or posters without the light blue guidelines. And if we submit that, you see we have the same image we had before without the blue lines in the graphic image. You'll notice that we've seen before the chromosome ideogram at the top when we navigated to this page in a previous video. It's optional whether you want to display this or not. So we'll go back to the configuration page and turn off the ideogram, and the image will disappear. We'll also turn off the blue bars while we're here. Let's configure one more time. The other options are fairly obvious what they're going to do. Display the labels, display the description. There is one option that can be a bit surprising, however. If you unclick the Enable Highlight with Drag and Select option, then the dialog box that showed up earlier when we drug our mouse to the right over the exon will disappear, and you automatically zoom, which is fine unless you forget you did it, and then it's problematic. You have to remember to come back in here to the configuration page and turn it back on. So let's unclick the box and go back to the browser. And you can see that if we put the mouse on either side of the 3' end exon at the end of the SLC6A5 gene, it automatically zooms directly to the location, and we no longer have the option to add the highlight. Note that here you can see the way the untranslated regions, UTRs, at the ends of genes are represented. They are a half-height box. The stop or start codon is colored green or red. Here you can see the stop is colored red. We can still add a highlight to the whole gene using the right mouse button on the gene annotation itself in the window. You can highlight the gene,
zoom out by a factor of 10 and another factor of 10, and you can see that the gene itself is fully highlighted right to its very edge. This works for any annotation on the screen, but if you want to put a highlight over any other randomly selected region, then you have to go back to the configuration menu and check the box. Another checkbox on this page, Show Track Controls under the main graphic, is a way to speed up the loading of the browser image. The screen will draw faster if the track controls below the graphic are not there. But you must come back to this configuration page to turn on any other tracks. Let's uncheck that box and we'll look at this page first. And you can see that on this page we have the same blue bar groups with all the tracks. They are all expanded. And for each one of the tracks you have the short label. This is the label that appears below the browser graphic near the pull-down menus, but these will not appear on the main page when we go back after unchecking this box. And we also have the long label, which is the description of the track you get at the top of the data in the browser image. Let's go back to the top of the page and submit. You see that now we have the browser without the track controls below the browser graphic. Let's go back once more to the configuration page, but before we do, let's make note of the long label here, chromosome bands localized by FISH mapping clones. That's the long label that you see in the track controls on the configuration page in the mapping and sequencing group. You can see the chromosome bands localized by FISH mapping clones. The track is turned on to pack and is one of the tracks turned on in the browser image. Let's go back now and turn the track controls back on in the image. We'll turn the ideogram back on as well and hit submit. You can see that the long label is here in the image, and it's also what you get when you put the mouse over the label above the track control pull-down menu below the browser graphic. That concludes our conversation about the configuration page and a number of configuration options for setting up the browser the way you like. This conversation about configuration will be continued in Part 3 of the Browser Basics series of videos. In Part 3, we will also look at navigation in the browser using DNA sequence. Please note that we conduct full-day and two-day on-site trainings at your institutions. Prices are reasonable. Visit genome.ucsc.edu/training/. Thanks for watching and thanks for using the UCSC Genome Browser.
Welcome to Part 3 of the Basic Browser video series. In Part 1 of the series, we focused on the use of accession names, the many ways that identifiers of various kinds can be used to locate genomic locations and annotations. We also saw a few configuration options for setting up the browser. In Part 2, we featured more ways to set up the browser to your liking, as well as several options for exporting images to use in posters, papers, and presentations. In this installment, we will continue the conversation about configuring the browser and show how to use DNA sequence as a device for finding a location. At the end of Part 1, we found ourselves on chromosome 11 with several data sets turned on. That's a convenient location to begin this installment as well. To make it easy to find that location again, we saved the configuration for easy access. The Saved Session feature is the subject of a separate tutorial in the UCSC browser video collection, so it will not be presented here. The session was saved under the username VideoDemo1 and the session name HG19_nav1. The session can be accessed directly in any browser using this URL, genome.ucsc.edu/s/video videodemo1 with a capital D /hg19_nav1. This returns us to the same location with all the configuration options intact. Note that the following tracks are turned on: alternate haplotypes, but there are no data for this track at this location in the browser; chromosome bands, UCSC genes, and OMIM genes, and we are at a 5.5 megabase region of chromosome 11. A good way to get around in the browser is to use DNA sequences. So let's get some DNA from a gene to use as starting material. Let's click into the details page of SLC6A5 and find out what it is. Turns out it's Homo sapiens solute carrier family 6, neurotransmitter transporter, glycine. A lot of other details are provided here as well, but for the moment, let's just get some DNA sequence. We'll scroll down the page just a little bit, and we'll get the mRNA sequence, and then grab a chunk of mRNA right out of the middle of it. I will copy that. Then we'll go back to the browser and just paste the DNA into the position box. If that DNA is unique or not, Blatt will show us a page of matches where we can go to that location on the browser. So here we are on a page with a single match. And if we hit the browser link, then we'll go to a 52 nucleotide location. Blatt is tolerant of some mismatches. So if I paste this 52 nucleotides back in and just remove a couple of G's here and maybe insert a couple of C's right here and then hit go, Blatt will still find it, but now it finds several smaller hits for the segments that are uninterrupted on other chromosomes as well. But the biggest hit, the one with the highest score that spans the full 52, is still on chromosome 11. And if I go to the browser using that link, here's our 2 base deletion, and here's our insertion over here where I added a couple of bases, shown as a little tick mark between the bases where it was inserted. Blatt will work well when you have nucleotide probe to put in the box of 22 bases or more. And it works a little bit as you get smaller, down to around 16, but below that, it doesn't work at all. In that case, there's a feature of the browser will let you find strings of nucleotides in the current browser window. It won't find them all over the genome, but if you go into the mapping and sequencing blue bar group below the browser graphic, there's a track called Short Match. If you click into Short Match, it tells you that you can use anything between 2 and 30 nucleotides. And let's just put in GCG. You'll see also that the IUPAC ambiguity codes are supported. So R is for purine, G or A, Y is pyrimidine, C or T, and so forth. So if we just hit submit, and we'll find any occurrences of GCG, and it'll also find such occurrences on the opposite strand. So a CGC here on the minus strand is also a match. It'll find all stretches of that particular nucleotide string in the current browser window. It is not possible, however, to export a list of all of the occurrences of this string via the table browser as it is for other tracks. Another useful feature of the browser is drag and zoom, or drag and highlight, depending on which choice you make in the menu that appears. If you put your mouse up in the scale bar near the top of the browser graphic and drag it to the right or left, it will highlight a region. Let's highlight the region around this 2 base deletion in the Blatt track that we made. And put a single highlight here. And let's zoom out by a factor of 3. And let's select a region next to it to highlight and change the color. Let's make the color much darker and add a second highlight. So you have 2 highlights side by side, and you can see how the colors stand up when you zoom out. If you zoom out by a factor of 10 or more, the lighter color starts to get more difficult to see as you get farther and farther out. So it's a good idea to use a darker color if you're going to zoom out. You can put your right mouse button over the highlight, and you have the option to remove a particular highlight by using the option in that pop-up. Another feature of the browser that can help when you're configuring it to your liking is your ability to drag tracks up and down and rearrange them on the screen. Ordinarily, the tracks appear in the same order that the options appear among the pull-down menus below the browser graphic, but you're not constrained to using that ordering on the screen. If you put your mouse over the text space on the left side of the browser graphic for any track, you can drag tracks up and down and put them in any order that you choose. Another option that you get when you put your mouse over the region in the scale bar near the top of the screen is to zoom in. You can zoom into any specific region that you select. On any spot of the browser, there is a context-sensitive right-click menu. If you put your mouse over a specific item in the browser graphic and use the right mouse button, you get a menu that lets you zoom to the full length of the item. In this case, we selected a gene. You can highlight the entire gene. You can get the DNA. You can click into the details page that we've been to before, where it shows you all of the information about the gene itself. And you can go to the configuration page, where you can turn off the splice variants. This has the same effect as using the small button on the left side of the track in the image. So let's just zoom to the gene and observe the full-sized gene filling the entire window. Let's turn off some of the data tracks and leave just the gene set on. So we'll turn off the alt haplotypes track, the cytoband track, the OMIM track, and the short match track. We'll also turn off the BLAT track. That leaves us with just our gene in the window. Let's zoom into the exon right here in the middle of the screen by selecting it from the top of the window, and we'll zoom in even a little further down to get to the amino acid level. And let's look at configuring the scale bar at the top of the page. You can see that we have this scale bar in roughly the middle third of the page, and the genome assembly is listed next to it in the browser graphic, although it can be removed using the configuration button that we visited in part 2 of this Browser Basics series. Let's click into the scale bar configuration button on the left side, and you can decorate the graphic just a little bit by putting in a title such as, "This is my title," and then you can add an assembly and a position to the browser graphic and submit that. So now you have a new row at the top where it says, "This is my title," and the assembly and the position are listed here in another row of text. Let's go back to the configuration window, and we'll turn off the title, assembly, and position, and switch the display mode from dense to full. You can see now that we have the amino acids of all 3 reading frames showing in the browser below the DNA sequence. And so you can see that one of the 3 reading frames is going to match the amino acid sequence of the exon that we have in the window, YVVLV and YVVLV. If your gene was being transcribed on the opposite strand, you can reverse the orientation by clicking on the little arrow on the left. Of course, in this orientation, the translation does not match the reading frame of the gene we have in the window currently. Let's turn the DNA base sequence back to the plus strand, and we'll go back into the position bar configuration and turn it from full back to dense and submit that. And we'll look at another way to navigate in the genome browser. You see here we're at a 48 base window in the SLC6A5 gene. And one option is to use DNA sequence homology to jump to the same location in other genomes. So if you go to View in Other Genomes, Convert, in the top blue bar menu, you see that the default is to go to another human genome. You can go to the HG38 assembly or back to HG18, or you can go to other animals. Human and mouse are the most widely used on the browser, so they come up at the top. Let's just accept the default and go to the HG38 genome assembly and hit Submit. For a small region, especially an exon, this is likely to be a really good single hit. If you're zoomed out and have a much larger region, or if you're going to an animal that's more distantly related than one human genome assembly to another, you're likely to have multiple hits on this window here because of rearrangements in one lineage or the other since the last common ancestor. So let's just click into this link and you'll see that here we are in the same region of SLC6A5. Amino acid YVVLV is still in the window. It's possible then to get back to HG19 two different ways. You can use the View in Other Genomes Convert using homology again, or if you have navigated to a different location, you have another option. Let's go to a different location by dragging the window off to the left. For the last two human and the last two mouse genomes, you have the option to return to your previous location on the other assembly. Go over here to Genomes and choose the HG19 assembly. In this case, the browser just remembers your last location. So it's not using homology, it's using memory, and it's essentially setting up the browser just the way it was the last time you were on that genome. So if I click on HG19, you see that we're back at the 48 base pair window at the same region of SLC6A5 we were at before. So that concludes our conversation about how to get around in the browser and how to configure the browser to display the image the way you like it. Stay tuned to the video channel or subscribe to the channel for future tutorials on the UCSC Genome Browser. Please note that we conduct full-day and two-day on-site trainings at your institutions. Prices are reasonable. Go to genome.ucsc.edu/training/. Thanks for watching, and thanks for using the UCSC Genome Browser.